Okay, let's run through an example of what Tableau can do. This isn't meant to be a demonstration. I just want to go over the layout of the Tableau interface and introduce you to some of the unique terminology that Tableau uses. Okay, so Tableau is software that's designed to help you rapidly construct visualizations and perform exploratory analysis of data really quickly and easily. It also provides best practices and makes it difficult for you to make bad data visualization decisions. Okay, so you should know from working in GIS that data can be discrete, like months, land cover types, counties, or continuous, like rainfall levels, slope, income, things like that. So when you add data, it comes in spreadsheet form, and Tableau looks for the type of data and tries to assign it. Tableau automatically places your spreadsheet data into one of two groups, dimensions and measures. This is the terminology. So dimensions are discrete, categorical data. Think descriptions. Dimensions are like categorical data. Dimensions, another way to think about it, it helps describe the granularity of the data. So you might have country, state, city, county, those kinds of things that get at the scale or how you're aggregating your data. Qualitative data assigned as a dimension. Those go up at the top here. Okay, continuous data is automatically assigned as a measure. This is typically the quantitative type of data. Data that's classified as a measure can be aggregated based on a dimension. So, for example, you could have total sales by region. So region would be the dimension and sales would be a measure, and you would sum them. Or you could do average precipitation by watershed over some period of time. So time is tricky because it can be both a dimension and a measure, but Tableau makes it really easy for you to convert back and forth. Okay, so these things here, these are called cards. The pages filters, marks, that section is called the cards. Cards are like controls. Dragging your dimensions or your measures onto the cards area lets you access the controls like changing the color or the size of a mark. It doesn't change your data at all. It doesn't change the way the axes are organized or anything in this main display. It just gives you control over how you're basically symbolizing the data. Marks are the choices you have for visually encoding. So remember, when I say encoding, I mean the way we represent the data with things like length, area, color, angle. And you can see that here. You've got color, size, you can change your text. So this is just the way it's seen, the way it's organized happens over here in the main data panel. And it's literally, you can just drag these in here, or you can drag them up to the rows and columns, which we're going to talk about right now. Okay, so you use the rows and columns to create your visualization. And this is where it appears, is this main panel. The rows and columns are the way you organize it. You can drag and drop from the dimensions and measures into the rows and columns section to populate the X and Y components of your chart. Or sometimes you can drag the dimensions and measures right onto this main view window, and Tableau will populate the rows and columns using best practice algorithms. Just note that Tableau aggregates row level data and rolls it up to a higher category. So when you put stuff up here, it will automatically show you the sum, like sum of precipitation or the sum of, sales or profit or, population sizes. Tableau does this automatically so that you can break the data down to the level of detail that you want to work with. But notice that's just kind of a default thing that it does. A really good thing to know about Tableau is that Control-Z or undo is brilliant. It works as many times as you want, going all the way back to adding a data set. It'll just back. This is completely different than working with ArcMap that has a complete conniption when you try and Control-Z or just ignores you entirely. Okay, let's work through a quick example. This data set is dealing with H-1B, which are temporary visas that foreign workers can apply for when coming to the U.S. So this is just a data set found on Kaggle. It's organized in a way where the rows are each different visa petition and the columns are these things. It's just a spreadsheet. The columns are like the employer name, so the company submitting the petition for the person, the standard occupational name, the job title, the prevailing wage, the year that the petition was filed, the city, and the state. It's very simplified, and it's just over this period of time. So what could we learn from this data? What might we discover? So have petitions for H-1B visas increased over time or decreased? Which company in the US files the most petitions? What kind of job, like the description of the job, receives the most applications? Which company offers the highest salary? Which jobs garner the highest salaries? Where are the cities and states that file the most petitions? How do salaries vary, etc.? Right. So again, I don't mean this to be a demonstration. I'm not going to show you how to use Tableau. I just want to introduce you to some of the capabilities of the software. So first of all, you're going to load your data. Just notice that you can put a whole bunch of different file types in here, and there's a More button usually below this, so that if you don't know what the format is, you can just hit More and it'll search for all usable data types. Like I said, you can change your data. So, in Excel, if something is the property for a data set is string or number or something like that, you can go in Tableau and just update the properties of data, which is pretty handy. All right, do petitions increase over time? Like I said, the automatic is to show you, this is year down here, show you the sum. So this is just the most basic thing. What's the count, and has it increased or decreased over time? We can quickly add filters. So you could drag one of your dimensions or measures over to filters. So here we took employers, so employee name or employer name, we dragged onto the filter and just said, let's just look at the top 10, and then it gave them each unique colors. But it's a drag and drop situation, which is brilliant about Tableau. Okay, which company files the most petitions? So we've gone from time series to a bar chart and filtered it to only look at the top 50 employers filing the most petitions. You can just, going to the analytics, throw in an average line. So it's really easy to make these things look powerful very simply. The key is you have to understand your data, and you have to be a little bit curious. So what kind of job receives the most applications? Another bar chart with an average, a tree map. There is, I don't think I have a picture of it. Over here, there's a show me that has all the different plot types that Tableau can create for you. And it tells you might want to try using 1 dimension and 2 measures. It's brilliant. Okay, so what kind of job receives the most applications? This might be organized by sector, and then the jobs within each sector or something like that. Salary, bar chart starting at 0, thousands of dollars, filtered by the top 50. So we're not looking at all, 800 employers. We just are making it manageable. Highest salary, again, ranked. We can make maps. I'm going to warn you right now, they're not pretty because the only coordinate system that's allowed is Web Mercator. So all of the north is enormous and dominates the map. But there you go. You just drag and drop, and if there's a spatial component, it'll make a map for you. So we get a sense of which states and cities are filing the most petitions. Box and whisker, looking at averages or means or median salaries across a select number of states. The relationship between salaries and petitions. Good stuff. That's it. Thanks.